This is CCEA A2 Pure Maths. We're looking at integration. We're looking at some past paper questions. This is a past paper question then from C4 June 2010, and the same as question 5. So two different parts here. First of all then is a substitution one. So we're looking to find the integral of 3x over the square root of x minus 2 dx, and we're told to use the substitution u equals x minus 2. We need to find then du by dx, and in this case then it's going to be 1. What's also going to be useful for us is if we rearrange this and we get x equals u plus 2. We're going to be using that a little bit later on. So let's start substituting in our information, and we can see where we go from here. So it's 3x all over the x minus 2, so that's going to be the square root of u. I'm going to go ahead and write that as u to the power of a half. Hope that's okay. And then it's going to be dx by du. That's the way we use our substitution formula. So the x we can exchange for a u plus 2. The dx by du is just going to be a 1. You flip that upside down, you still get a 1, and we're good to go. So it's not too bad. So it's 3 upon u plus 2 all over u to the power of a half du. That gives me the integral of 3u plus 6 all over u to the power of a half du, and that gives me the integral, so 3u divided by u to the power of a half gives me 3u to the power of a half, and then 6 divided by u to the power of a half is going to be 6u to the power of minus a half du. So we go ahead then and we can now integrate. Add 1 to the power gives me 3 over 2. Divide by the new power. 3 divided by 3 over 2 is 3 divided by 1.5, so it goes in 2 times. So it's 2u to the 3 over 2. Add 1 to the power gives me a half. 6 divided by a half then is 12. 12u to the power of a half plus c. We now need to change back, so we're going to get then our u exchange for an x plus 2, sorry, an x minus 2. X minus 2 to the 3 over 2 plus 12 x minus 2 to the power of a half plus c. Incidentally, this would give you full marks. You don't need to factorize out the last bit, however you can if you wish. So factorizing out the last bit, we could take out an x minus 2 to the power of a half here. If you take out the x minus 2 to the power of a half, you get 2 upon x minus 2. So if you take a half out of that, you just end up with a 1. So it's going to be 2x minus 4. You take out the x to the power of a half, x minus 2 to the power of a half here, you just end up then with 12 plus c. So that gives me x minus 2 all to the power of a half upon 2x plus 8 plus c. Part B. Integral between pi over 4 and 0 of 4x cos 2x plus c. I hope most people can see this in as an integration by parts, where this is going to be our u and this is going to be our dv by dx. So u is 4x, dv by dx is cos 2x, du by dx is 4. And then v, if I integrate cos, I get sine. If I integrate cos 2x, I would get a half sine 2x. That means my integral now becomes u v, so we can tidy this up a bit. The 4 times the half just gives me a 2, so it's 2x sine 2x. Of course it's definite, So we've got to put in pi over 4 and 0 there, minus the integral of v du by dx. So again, that tidies up to give me 2 sine 2x dx. So my integral now becomes 2x sine 2x. So what's going to happen here? If I integrate sine, I get minus cos. If I integrate sine 2x, I get minus a half cos 2x. So the 2 cancels with the half, the minus cancels with the minus there. So I just end up with plus cos 2x. And I put in pi over 4, 0. If I substitute in pi over 4, then this gives me pi over 2. So we have then pi over 2 upon sine pi over 2, and sine pi over 2 is just 1. So that's going to be pi over 2. Cos pi over 2 is of course 0. So that wee bit disappears. So that's all I end up there with if I put in pi over 4 into this. Sorry, move this up a bit for you. I then want to take away, whenever I put in 0, put in 0, this bit just disappears. It disappears because of the sine and the x. 0 of cos, however, if we remember, then is 1. So my final answer then is pi over 2, take away 1.